So this is it. You type 3 characters, py, and the file name, hit enter, and a window opens. A browser window. Nothing fancy yet. An address bar, a few buttons, a blank page that says hello. Takes about half a second. And in that half second, more happens than most people who've used a browser their whole lives ever think about. Here's the thing I want you to sit with before we touch a single file. This isn't Chrome with a new coat of paint. There's no Chromium hiding in here. No web engine we borrowed. When I say we're building a browser from scratch, I mean the parsing, the layout, the rendering, all of it, eventually written by hand. This first phase? It's the skeleton. The part nobody claps for. But get it wrong, and everything you build on top of it wobbles. Let me show you the shape of it first, because once you see the shape, the details stop being scary. Everything lives in 3 folders: config, core, and UI. And there's one rule that holds this whole project together. It's almost embarrassingly simple. The arrows only point one way. Config depends on nothing. It's just facts and choices, the app's name, the window size, where the logs go. Core sits on top of config and handles the plumbing every part of the app needs, like logging. And UI, the stuff you actually see, is allowed to lean on both. But config can never reach up into the UI, ever. And that one restriction is what keeps the engine testable later, without a single window on screen. Remember that. It'll pay off 3 times before this video's done. Okay. You ran main.py. But how does Python even know that main.py is the thing to run, and not one of the 15 other files sitting right next to it? Simpler than you'd think. Whatever file you name on the command line gets a special label. Python calls it _main. That's the whole trick. And at the bottom of main.py, there's this line you've seen 100 times, and maybe never questioned. If name equals main. In the file you ran, that's true, so the code underneath fires. In every other file, the same line is false, because they were imported, not run directly. Same line of code. Different answer depending on how the file got loaded. That's how one file can be both a program you run and a library you import. Before that guard ever runs, though, the imports at the top go first, and imports do more than you'd guess. The first time Python sees a module, it finds the file, runs it top to bottom, every class, every function definition, every line, then files it away in a cache. Import it again later? Python doesn't rerun it. It just hands back the copy it already made. That runs exactly once rule is quietly important. It means our constants file, the one holding the app name and the window size and the log path, loads a single time, and every other file that imports it is looking at the same object in memory. Not a copy. The same one. So it behaves like a safe global. One source of truth. Change the default window size in one place and the whole app agrees instantly. That's not an accident. That's why it exists. Little detail I love in here. The home page is about :home with a colon like a real browser scheme, but it's not a real address. It doesn't go anywhere. It can't. We haven't built networking yet. It's a placeholder wearing a costume. And honestly, leaving little honest markers like that in the code, a name that says this is pretend for now, saves the next person a lot of confusion, including future you. Now, we needed something to draw windows and catch mouse clicks. We went with PySide6, the official Python binding for Qt. Quick on the alternatives, because people always ask. The standard library option tkinter is too primitive for custom drawing. The Chromium embedding ones are off the table on principle. The whole point is to not use a browser to build a browser. And PyQt is basically the same thing, but with a license that bite us. PySide6 is free for our use, and it gives us a raw canvas to paint on later. That last part matters more than anything. One thing that trips people up. When you write Qapplication in Python, you're not really making a Python object. Underneath, Qt is a giant C++ framework, and your Python line reaches across the language boundary and builds a real C++ object over there. Your Python variable is just a thin handle holding onto it. Keep that picture in your head, a Python handle, a C++ object it points at. Because in about 90 seconds, it's going to explain a really nasty class of bug. Here's the heart of every GUI program ever written. It's a loop. That's it. Wait for something to happen, a click, a key press, the OS saying, hey, your window needs repainting. Figure out which widget it's for. Hand it over. Then go back to waiting. Round and round, thousands of times a second, for as long as the app is open. And there's one call that starts that loop, app.exec. It's easy to overlook, it's one line, but it is doing all the work. Leave it out and watch what happens. You create the window, you show it, and then your program just ends. reaches the bottom, exits, and the window blinks out of existence before your eye can even catch it. Milliseconds. Exec is the thing that keeps the whole program alive and listening. It's the loop. When it finally returns, the app is closing, and what it hands back is your exit code. All right, the bug I promised you. This one has cost people real hours. Remember, the Python handle and the C++ object are two different things. Now imagine you create your window inside a function, and the function ends. The Python handle goes out of scope. Python's garbage collector sees nothing's holding it and cleans it up. And here's the cruel part. Even though the event loop is running, even though the window is right there, it can get yanked out from under you. The window flickers and disappears, and you swear you did everything right. The fix is almost anticlimactic. Our application object just holds on. It stores the window as an attribute, self.window, and the Qt app the same way. A permanent reference that lives as long as the program does. Nothing gets collected because something's always holding the rope. It looks like a boring line. Self.window equals. It is not boring. It's load-bearing. Delete it and the whole thing falls over. Now let's actually walk it, start to finish. This is the part I'd want you to be able to recite half asleep. Main runs 5 steps in order, and the order is not negotiable. Step 1, parse the command line. Did they pass debug? Good to know. Step 2, build the settings. One little immutable object that says how this run should behave. Window size, debug on or off the home page. Step 3, and the order here really matters, turn on logging before anything else gets built. Because if a subsystem coughs during startup, I want that cough in the log. Configure logging after you build things, and you've thrown away the most important messages you'll ever get. Step 4, build the application object. And that's what creates the one and only Qt application, and then the window. Step 5, run it. Show the window, start the loop, and block right there until you close it. 5 steps. Args, settings, logging, app, go. If you remember nothing else about main, remember those 5 in their order. Quick detour on that settings object because there's a nice decision buried in it. It's frozen. Immutable. Once it's made, you cannot change it. Try to, and Python throws an error in your face. Sounds annoying. It's actually a gift. It means no widget, buried 5 layers deep, can quietly reach in and flip a value and leave you wondering why the window's the wrong size. If you want different settings, you make a new settings. The state flow stays honest. You can always follow it. So the window gets built, and the window is the most important character in this whole story, so let me introduce it properly. It's the place where everything comes together. It builds 4 little widgets, the nav buttons, the address bar, the page area, the status strip, drops each one into its spot, and then wires them up. All the assembly happens here, in one class, in one predictable order. Widgets first, wiring second, and only then does it load the home page. You can't connect a wire to a widget that doesn't exist yet, so the order isn't style, it's necessity. Here's the design idea that makes the whole UI pleasant to work with. The widgets are dumb. Deliberately, proudly dumb. The address bar's entire job is this. You type something, you press enter, and it announces, hey, somebody submitted this text. That's it. It does not decide whether you typed a URL or a search or a typo. It doesn't navigate anywhere. Interpreting what you meant is somebody else's job. The address bar just reports what happened and gets out of the way. That announcement has a name in Qt. It's called a signal. And the beautiful part, the address bar has no idea who's listening. Could be one thing. Could be 5. Could be nothing. It just shouts into the room. Somewhere else, the window is listening, and it decides what the shout means. The two never import each other. Never call each other directly. You could add a second listener tomorrow, say, something that records your history, and you wouldn't touch the address bar at all. That's the payoff. Loose coupling. Things that don't know about each other can't break each other. So if the widgets don't talk to each other, who's in charge? The window. Every widget talks only to the window, and the window coordinates all of them. It's the air traffic control tower. The planes don't radio each other. That's how you get mid-air collisions. They all radio the tower. 4 widgets, 1 coordinator, every wire meeting in a single method you can read in 10 seconds. When something goes weird later, you know exactly where to look. There's one room where all the decisions happen. Now this widget, the page area, looks like the most boring one. Right now it just shows a little welcome message. Centered text, nothing happening. But this is the single most important widget in the entire project, and it's because of what it will be. This is the exact spot where our own rendering engine is going to paint later. Real parsed HTML. Real layout. drawn by us, pixel by pixel. We built the empty box now in the right place, wired into the window, so that when the engine's ready, it just slides in. Nothing around it has to move. There's a word for that, a seam. A place you deliberately leave open so future work has somewhere to plug in. And there's a real judgment call hiding here that I want you to notice. We did not build a history system, or a networking layer, or a page model, because there's nothing to put in them yet. Building all that structure now would be over-engineering. Guessing. But leaving the seams, the empty box, the thin handlers that just log for now, costs almost nothing and saves you a rewrite. Knowing the difference between those two? That's most of what good architecture actually is. And one thing I want to be really clear about, because it's a trap people fall into. That welcome message? Qt is drawing that for us. It's Qt's built-in text rendering. It is not our HTML engine. We have not built an HTML engine. Not one line of it yet. I'm telling you this because it'd be easy to look at rich text on screen and think we'd done something we haven't. We haven't. That comes later, and it's the hardest, most fun part of the whole project. Let's step all the way back and look at what we've actually got, because it's more than it looks like. There's a thin front door that just starts things and steps aside. An immutable little config object that everyone reads and nobody can corrupt. A logging system that's recording from the very first breath. One Qt application, one window, held alive on purpose. 4 dumb, decoupled widgets that announce instead of command. And a coordinator that turns all their noise into behavior in one audible place. And the arrows still point one way. UI leans on core leans on config leans on nothing, no cycles. No file secretly reaching back up the chain. Which means every piece of this can be tested on its own, and every future subsystem, the networking, the HTML parser, the layout engine, the JavaScript, has a clean place to land that already exists. I'll leave you with my favorite thing about this whole setup. Run it again, but this time add debug. Watch the log. Because those lines print in the exact order everything happens. Settings built. Logging configured. Application starting. Window ready. The log isn't describing the startup. The log is the startup, narrating itself, live in the right order every time. So if you ever want to really understand this code base, don't read it. Run it in debug and follow the log down the screen. It's the execution timeline printing itself out for you. That's the skeleton. Boring to some people. But this is the part that decides whether everything on top of it stands up straight or leans a little more every phase until it collapses. Next time, we start putting muscle on the bones, the networking layer actually fetching a page over the wire with our own code. And then the real monster after that, parsing HTML into a tree we can render ourselves. Before you go, I'm actually curious what you think. When you look at this, one immutable settings object, dumb widgets, one coordinator, what would you have done differently? Because there's no single right answer here, and the good arguments are the fun part. Tell me in the comments. I read them.